When many developers hear the word accessibility, they picture a strict compliance checklist meant only for users with permanent physical or cognitive disabilities. But an interface built with broad accessibility standards immediately helps a user trying to read a screen in blinding sunlight, navigating one-handed with a broken arm, or struggling with a slow internet connection. Look at this list of common developer mistakes. There is a dangerous assumption that usability issues can simply be patched at the end of a project. By the time a product reaches its final stages, the core architecture is already set. Software built with accessibility in mind from day one is simply easier to read, navigate, and understand. When we engineer an application to proactively include a wide range of abilities and environments, we create software that functions reliably in unpredictable real-world conditions. The deepest layer of any application lives entirely out of sight from the end user. This underlying HTML markup communicates directly with browsers and assistive tools. If you build a user interface entirely out of generic div tags, you give the browser a page full of identical, meaningless boxes. Assistive software like screen readers cannot distinguish a navigation bar from a footer. We fix this by writing semantic HTML. By using specific elements like nav, button, and table, we assign native, readable meaning to every section of the page. Without this explicit code foundation, all the visual and interactive layers built on top of it will inevitably fail for users relying on assistive technology. Moving up the stack, we reach the interactive skeleton. Every user must be able to move through an interface and trigger actions using only a keyboard. This requires defining a logical tab order, so a person can hit a single key to jump cleanly from one form field to the next, and finally to the submit action. As they tab through, they must know exactly where they are. Developers often remove the default browser focus outline for aesthetic reasons, but doing so forces you to replace it with a clear, highly visible alternative. This interactive layer is also where we encounter the modal trap. A pop-up dialog box can easily break an entire application if the keyboard navigation isn't carefully constrained. When a modal opens, keyboard focus must immediately enter it. It must stay locked inside that window until the user is finished, and the escape key must cleanly close it. Defining strict keyboard pathways and obvious focus states removes confusion. It provides the visual feedback necessary for users to navigate complex interfaces with confidence. The final layer is the visual surface. This is where ambiguous design choices create immediate friction for the end user. We start with typography. Tiny text, dense blocks of paragraphs, and low-contrast gray fonts force users to strain simply to consume basic information. Look at this documentation on bad color practices. A solitary red dot indicating an error communicates absolutely nothing to someone with red-green colorblindness. The correct approach, shown below it, pairs that indicator with explicit, accessible text, like the phrase status blocked. That same need for explicit text applies to form inputs. Disappearing placeholder text vanishes the moment someone starts typing, causing them to lose context. Every input needs a permanent, distinct label. The calls to action must be equally clear. As this guide illustrates, vague terms like click here or submit should be replaced with exact descriptions of the action, such as save review settings. When a user inevitably makes a mistake, error messages must be highly specific, tell them how to fix the issue, and appear directly next to the relevant input field. And if the interface includes AI features, any generated output must be clearly labeled as a suggestion, never a final system decision, while allowing the user to seamlessly edit or reject it. A successful visual surface eliminates guesswork. Communication is entirely unambiguous, so no one ever has to wonder what the system requires them to do next. We've examined the complete architecture, a semantic code foundation, an easily navigable skeleton, and a clearly communicative visual surface. These concepts don't exist in isolation. They form an interconnected system of intentional design, where each layer supports the others to create a stable user experience. To verify that system is working, developers should run through this exact accessibility checklist for every major screen they build, ensuring clear headings, labeled forms, and descriptive buttons are always in place. Building with accessibility in mind moves a project past the minimum requirements of compliance. It ensures every line of code serves the widest possible audience without unnecessary friction.